Today's lesson is on circles, and it will cover pages 197 to 198. In a circle, we have something called the radius, and the radius starts at the center to the edge. Now, the radius can go in any direction. Everywhere we go, this is a radius, and it should be the same length. That's one of the unique qualities of a circle. Now, the plural of radius is radii. So if you see radii, it's referring to more than one. Before you start question 1, it's important to review the steps to constructing a circle using a compass. So this machine here is a compass. There's a point on one end, and you can put your pencil into the other, and it allows you to draw a circle. Your first step is to set the radius with the compass width to the given radius. So you open up the middle part so that the points are touching one on each end. So for the first question, you would have one point touching A and the other point touching B. Then, without moving the width between your compass, you're going to move it to set the point that does not have the pencil on your center point. So the center point would be like O for origin. Then, without changing the width, you need to trace it all the way around. So sometimes it's easier to move the paper, but you'd move your compass point all the way around to make a perfect circle. We will go over this in class, but if you're away, maybe look up some videos and try match up the 2 points, get your center one there, see if you can twist it all the way around to make it even. For question 2, if you have a circle and your center point, part A asks you to mark any 2 points on the circle. So any 2 places you could make a dot, and you're going to label one C and one D. Yours don't have to match up with where I've drawn them. Then for part B, they're asking you to construct a line segment. So you are going to draw a straight line that goes from the center to the point on the outside. So make sure mine won't connect as easily, but make sure you're connecting from the center all the way out to the edge. Then they're going to ask you to measure. So you'll need to line up your ruler, and you're measuring from the center to point C, the center to point D, and seeing what the measurements are. Now, you should notice that they are the same length if you actually have a proper circle and a proper center. So the radius is always the same no matter which way it's pointing up from the center, which is why they should equal each other. For question 3, we'll need to introduce the term diameter. A diameter is the distance across a circle passing through the sentence. That means it's twice as long as a radius, which goes from the center to the edge instead of all the way across. The diameter can face any direction as long as it touches both edges and passes through the center. For question 3, they're going to ask you to identify the radius from the diameter. So if the diameter is 12 centimeters, you need to divide that number by 2 to figure out the radius, which would be 6. And you need to also remember that it is 6 centimeters, otherwise your answer is incorrect. Question 4 will have you do the reverse. They will give you the diameter, the radius, and you will have to find the diameter. So if the radius is 32, the diameter is like 2 radiuses put together, so it would become 64 millimeters. Question 5 is going to give you a chart where you have to fill in the missing radius or diameter for each circle. Now, the circles are vertical columns, so if the radius is 3, the diameter is 6. If your radius is 4 centimeters, our diameter would be double that, so it would be 8 centimeters. Whereas if we look further, if our diameter is 4 centimeters, our radius needs to be half, so it would be 2 millimeters. Sorry, make sure you have the correct unit. So they'll give you at least one of the numbers. When you get to the last part of the chart where it talks about R, use algebra to think about what do you put to show double the value of R. Question 6 will ask you to draw and measure the diameter. So we need to remember that diameter is going the entire way across. So you will need to grab a ruler and a pencil. Make sure that the ruler is passing through each edge and the center, and then draw a line using the ruler to pass through. Then you can set up your ruler to measure. Now, mine will not be the same as yours, but if I look here and I line up the ruler, I am going from, here's the center, I have 1 inch, 2 inches, and 3/4 of an inch. So I might write that as 2.75 inches or centimeters. To find the radius, we're only passing halfway through the circle. So you'll start off with your ruler, and then you're going to draw just from the center to the edge, so it only goes part way through, and then you can measure. So if I look at this one, it's closer to just over 1.5, right? So it might be more like 1.6, to also include whatever unit you are referring to. Question number 8 asks you to make a circle with a specific measurement. So if it has a radius of 2 centimeters, and then drawing a circle with your compass that goes all the way around it. Question 9 tells you that the diameter in the circles are right at perpendicular. So what that's saying is that they make a little square in every corner. Now those squares are equivalent to 90 degrees. So when they ask you what the sum of the angles is, you would have 90 plus 90 plus 90 plus 90. When you add those all together, you will find that the sum of the central angles is always 360 degrees. I won't go through all of these examples for 10 and 11 with you, but I will go through part of them. The first question asks you to find these angles in the diagram and then circle the central angles. So if we look at BHD, we always go in the order they write it. The vertex of this angle is at the center of the circle. So this would be a central angle. If we look at AHD, well, the vertex is in the center, so we would also circle that one. Whereas when we look at ACD, the vertex is on the edge, so it is not a central angle because the vertex is not at the origin at H. Question B then asks you to name 2 more central angles, so 2 more where the center is at H. Question C says that if angle AHD is the same as angle CHF and they're both 45 degrees, what is the degree measure of these central angles? So if we look at AHD and CHF, they're both half of the 90 degree angle, right? That's why they're 45. So AHD would equal 45 degrees. FHI, how many degrees would that equal? So for each of these, you can write the degree measure. For part D, to find the sum of the central angles, use the angles that cover all the area without overlapping. So basically we're adding up all of these angles to see what they equal. For questions D and E, look at the angle BHC and then figure out what it would be, and you can write it on top. Then you can add them all together. Same thing for angle E. Or for question E, you will have to see what's the last angle left. If you have AHI and AHC, what's left? Well, it's just this space here. So what would you call that angle? And then what does it add up to? And then you're going to ask, does the sum of central angles depend on the angles used? You should have gotten the same answer every time. Question 11, Just says if a circle is divided into 6 equal parts, what's the measure of AOB? Well, all the way around is 360. How do you figure out what just one part is?